So I just started the recording, and today is going to be the second session of the orbital week, in which I'm going to be going through some interesting parts of the rocket science. And the Monday session already passed on Monday. We covered the overall topic of rocket science, and I think that you guys are a completely new audience. Last time we had really interesting people, and we had, let's say, Hazrat Bek, who was really, really into the stuff of what I was explaining, and he was really engaged. So you could, half of the talk was done by him. Today, we're going to be going through something called the propulsion technology, and I'm going to be showing the schedule right now. So this is how it looks. Just a second. Okay, so last time we covered this thing, and today we're going to be covering this thing. The topic is that are we good at it? So are we good at the rocket science? And I'm going to be talking about certain developments that occurred throughout the century, because the rocket science is a very, very well, people say it's a very old thing, but I believe that the real rocket science thing started in 1920s. It was the World War One, believe. Then it had extremely high peak of development in around 1960s. The peak was in 1969 when the space race was at its peak, because a lot of people invested. By people, I mean governments like the Soviets and the USA. So those countries spend a lot of money to developing the spacefaring technologies. And the pivotal technology is called the rocket propulsion. In fact, without the rocket propulsion, nothing would have happened at all. In fact, it's so pivotal that the first thing that happened in the rocket science was the rocket propulsion. So I'm going to be going through some basics of what it is, and then we're going to be analyzing the paper which I wrote on exactly evolution of rocket propulsion. So it fits very, very well. So, what is a rocket propulsion? In fact, the rocket propulsion is a very, very simple physics. In fact, it stems to the classical mechanics and involves the topic of the third law of uh, third law of Newton. I think I spelled it right. So, what does it say? It says that for every action, so for every single force, there's an anti-force, because, as you know, uh, the energy cannot be created. Energy, let me type it. I think that you would much appreciate if I type it. So, as you know, energy can not be created, nor can it be destroyed. It means that you're not able to fight someone and just by fighting him apply the force. That force would not exist on its own. Okay, there should be equal and very opposite force, meaning that if I create an energy, so if I produce a force, right, of, let's say, 700 newtons, right, then as I fight it, I'm going to produce a force which is going to be opposite to it, so it's going to be directly opposite, and the angle which is going to create right here is going to be 180, and it's going to be equal. So I'm going to receive an anti-force. That it's not official name, but I call it anti-force. It's very, very informal, by the way. Don't think that it's very formal and in university you're gonna have the exactly same terms. I'm just giving it you for intuition. Anti-force of 700 newtons. Why am I saying 700 newtons, not minus 700 newtons? Because anti-force already implies that it's gonna be negative. That's why I didn't plug in a minus. And that's why minus plus is going to be zero. It means that overall, the amount of force that was in the universe is zero. And it has to stay constant. At least it's not zero, but the change, right, should be equal to zero. You should not add anything and you should not remove anything. This is what the uh, Newton's third law says. And we use the Newton's third law to connect to the propulsion. So if you get something, right, and let's say, okay, let me put it in a way that's gonna be more understandable. Imagine a very typical scenario. Imagine you are on a sea. So this is like the Bassein, and by the way, the word Bassein, it exists. I think this word exists, and I didn't get it from the Russian word. Okay, so imagine that's a sea, right? And you are right here. This is your boat. Let's call it Aziz boat. Sorry, boat. So you're standing right here, and you're having in your hands basically a stone, right? And you're throwing the stone to that direction. As you throw that stone to that direction, you are connected to the boat. So it means that you're gonna move to that direction with the boat. This is a propulsion because you're using a certain material to propel yourself further in the opposite direction. The same way rocket works. You got the like you got the this is the saying, and you basically I think are able to say that, let's say you got several engines, and this basically is a very like simple like drawing. So this is the gas, so you're excreting the gas, so you're like getting the gas and um, like excreting it to the opposite direction of your movement. So the gas moves this way, you move that way. The more gas, the better. So as you know, it's all is a science, and obviously, like the scientists, rocket scientists, propulsion technologists, they like collect all the data, and they're able to properly identify how much gas should be like propelled, like which gas should be propelled, when, how much, at which angle. It's all that is a very very meticulous and very important job, which the like rocket propulsion technicians do. Okay. Um, yeah, this is pretty much it. As you know, the overall like propulsion technology didn't start with a gas. Of course, now you might be again very confused because I was saying that like like we are throwing out stones, and I said that now we have gas. Of course, the very very thing that you're the fuel. So we call it the fuel. The fuel that you're excreting, right, changed over time. So it all started in my timeline. Maybe it's like not really my timeline, but at least I follow this timeline. Started in 1920s when there was a guy called. So it basically started in several places independently. So it the propulsion itself, I believe, started in Germany with the person called Von Braun, who was a basically German, and he was a like a propulsion military individual, and he created a weapon with the propulsion because as you can see it looks like a weapon, like a bullet, but a big bullet. Imagine like a huge bullet coming and destroying your city. So he created that system, and um, basically in 1940s the idea of basically ballistic missiles. So the word ballistic missile comes from the basically like from 1920s when von Braun created first engines. Right, I just call them engines. We're gonna keep it very informal because I don't want to talk too formally, and I think I will not be able to talk formally. Okay, moving on. It became more developed. In fact, they use something called the solid fuel. Solid fuel, obviously, compared to the uh, liquid fuel, which is gas, basically gas, liquid fuel, is solid, right? And solid fuels, in fact, are used in almost all small rockets. Uh, have you ever um, used a like a small rock? I don't know how it's called. Okay, fireworks. Sorry, fireworks. Remember in the New Year, you purchased them from someone, then just throw it away, or like if it was a bigger one, you just did a firework and went up. You just have to ignite it. Do you guys remember it? Yep. Okay. Um, can you tell me like more about it? It would be nice if you turn on your like camera. I mean, sorry, not camera, but the video. I mean, video. Sorry, the microphone. Is it the same as you described? Can you give more specific example if there are some examples? What about you, Aziz? Maybe you talk as well. What do you think? Hard to put it in words. That's amazing excuse. I love it. So, okay. The problem with the solid fuels, however, is the fact that as soon as you ignite it, there is zero ways you are able to stop it. Like imagine you have to like shoot not to that direction but to that direction, and you already ignited it, and there is no way you're going back. This was a problem with the solid fuel propulsion system because it was very easy to lose the control of. So people came up with the liquid propulsion. I don't know where exactly it started, but I believe that in 1960s it peaked. Peak of in fact peak of investments, and this is why people came up with liquid propulsion. Okay, so what does liquid propulsion mean? Liquid propulsion is basically a mix of a lot of different um, elements, like oxygen, which is very combustible, like oxygen, I don't know, like hydrogen, and etc. In fact, the name of the like fuel is called LOX. I think we pronounce it as LOX, but obviously for the people from Uzbekistan or Russia or any countries from the or any post-Soviet countries, we know what this is, right? Anyone who knows Russian knows what it is. Anyone who knows it, like, definitely understands the like punchiness of it, the sheer humor that it brings. But okay, it's interesting. In fact, this is the chemical name of a certain liquid which people use um, for the liquid propulsion. I think we can move on. Yeah, as I said, it's very easily controllable because as soon as you turn in, you're able to turn it off, and you're able to control the amount of liquid like that goes away. If you want, let's say, like this much, you're able to put this much. If you want, like I don't know, this much, you're able to put as much as you want. So it's very easy to control it, and because of the fact that it's very easy to control it, people, NASA and SpaceX and some other countries, spacefaring organizations, they um, like more readily use it. Oh, I noticed that like there's only USAT, so it's probably gonna be just like 1 to 1. I hope that's okay, right? If that's okay, then I think I can just move on, right? I hope. Okay, I also hope so. Sure. Um, okay, and the uh, so since 1960s to this day and until 2020s, they've got a lot of different companies, different researchers working tirelessly to identify what is really the best like fuel, what is the best propulsion method, right? And we understood that the liquid propulsion is in fact really easy to get. It's just oxygen and some other chemicals, and if you combine it, you're gonna get a lot of like fuel. Now, if you have a lot of fuel, if you have a lot of fuel, it means that you have a lot of um, basically baggage. You have a lot of things to go up, like that you need to go up. And the more baggage you have, the more fuel you need. And the more fuel you need, the more baggage you need. So it's just going to increase exponentially. Okay. And this leads us to the fundamental problem of the space rocketry is that if you have like too big of a ship means like saying ship, it's going to be extremely difficult to go up because for such huge thing, you need a very large amount of fuel, and for a very large amount of fuel, like this thing results in a lot of space, right, which you need, and the lot of space taken up results in a lot of fuel that you need to get. Let's move on. Okay, so we just analyze some solids like fuel and etc. And apart from those, there are a couple of other innovative ways of propelling further to the space. So a lot of like couple, in fact, like maybe two to three innovative ways of going up, which are quite nice in terms of its like efficiency, but might not be really good in terms of its availability. As you know, there is something called the nuclear fusion. It's basically a way. I mean, that's a reaction, and the nuclear fusion reactions. Well, so far, by the time I'm recording it, at 2025, 9th October, uh, we don't have ability to really get energy from it, at least right now. And even if it's the most efficient way of getting the energy, it is least available, and because we don't really have any, ways to obtain the energy through these reactions. There's also another thing called the nuclear fission. Nuclear fission, on the other hand, is obtainable. At the same time, it is thought to be very impractical in ways that it is a new thing. And because of the fact that it's a new thing, especially in the like rocket propulsion industry, the way we obtain energy from it is very inefficient. And we have to think of a lot of other ways, a lot of different ways of obtaining the energy from the nuclear fission and nuclear fusion reactions, um, right? In order to like use it. Like if we don't know how to harvest that energy efficiently, then there's no way we're gonna use it, even if it's the most efficient energy source ever. It's like if you have a business which makes $1 trillion, but there is no way you can get that money, or like very hardly you're getting that money, then what's the point of running that business, right? So we are working on that, and I think that um, maybe by 2030 or 2035, the like the researchers are going to finally get to the point when they're going to be using the nuclear fission and fusion reactions to get the energy and run the rockets, right? Okay, this is pretty simple thing. Turns out it's much less difficult than I expected. Okay. In fact, this is where I want to end because I think that I'm able to divide this whole video into two different videos, this one and the next one, in which I'm going to go through my own paper because today I think I went over quite a lot and still it's very interesting. So I really appreciated your presence, guys, and I think that it's time for you to guys maybe ask some questions. I would really appreciate if you do. I would really appreciate if you do. You guys can answer. You guys can ask a question. Do you have any questions, guys? Maybe you guys speak. I don't have one, bro. First time knowing about the rocket science. Well, that's okay. Propulsion. That's all right. Sure. What about you, Aziz? Maybe you can ask any question.
Hi, I'm Ravi. What's the importance of uh, a rocket propulsion?
Hmm. So without
Importance.
mhm. So without the rocket propulsion, there would be no way we would be able to ever go up. Like as I said, to go up, you need to first of all drop this thing like this. So you know what? I'm gonna do this. I really wanted to never use this example, but I will use this example. This is gonna be a very, very nasty example. It's gonna probably very the worst example I could have ever given. But you asked me, so I'm gonna tell you. It's as if like you're farting. Like to go up to like fly, you're able to fart so hard that it just like you know you, you can just go up if you like fart really really hard. And in fact it's gonna be like something unrelated. There's gonna be season 3 of my really interesting anime called One Punch Man, and there in one of the final episodes, so the main hero Saitama is going to uh, like propel himself further with uh, with his fart, and he can go like larger than the speed of light, which is not possible, but it's an anime, so anything is possible, and I'm eagerly waiting for that moment. Okay, I really appreciate Roshanazam John was that you came, but the problem is I've just ended my seminar, so you're a bit late.
Oh yeah.
Mhm. Sure. Okay, I think that that's it. Bye.